China is rapidly transforming construction and manufacturing with AI-powered machines, and the scale of this shift is leaving Americans worried. China has spent decades building highways, bridges, railways, and entire cities at a pace that many countries struggle to match. During the last few years, the country has added another layer to this strategy. Engineers, government planners, and technology companies are bringing artificial intelligence and robotics directly into construction and industrial production. This approach has created what many observers describe as a robot workforce that can operate machines, coordinate construction fleets, and monitor projects with very little human involvement. The result is faster infrastructure development and a manufacturing sector that is becoming more automated every year. One of the most widely discussed projects took place on the Beijing-Hong Kong-Macao Expressway. A 157.79-kilometer section of this major highway was completed using a coordinated fleet of robots. Robotic pavers laid the asphalt, while automated rollers compressed the surface and drones inspected the work from the air. Engineers monitored the project remotely, while the machines carried out the physical work on the road itself. The machines relied on satellite navigation, sensors, and AI algorithms that allowed them to coordinate movement with centimeter-level precision. Construction experts say the automated approach significantly improves precision and efficiency. Traditional road paving requires multiple teams of workers who coordinate each stage of the process. Machines must move in perfect order to avoid uneven surfaces or structural defects. When AI controls the fleet, the software calculates the exact movement pattern required for each machine. This reduces human error and allows the equipment to maintain consistent quality along long sections of road. Engineers also reported that the automated system could achieve centimeter-level positioning accuracy, which is extremely difficult to maintain during manual construction. Speed is another major advantage. Reports suggest the automated highway construction project finished about 30% faster than traditional methods. Machines can operate continuously with fewer interruptions and fewer coordination delays between crews. These advantages allow projects to move forward more quickly while maintaining consistent construction quality. Robotic technology has also been used for complex structural engineering tasks. In Shanghai, engineers faced the challenge of relocating a historic building complex that weighed approximately 7,500 tons. The solution involved a coordinated team of 432 hydraulic walking robots. Each robot lifted a portion of the structure and moved in small synchronized steps. Together, the machines slowly shifted the entire building complex to a new position. The operation demonstrated how robotics can handle tasks that would be extremely difficult or dangerous for large human crews. The system behind the walking robots required extremely precise coordination. Sensors monitored weight distribution across the building, while control software calculated how far each robot would have to move during every step. The robots advanced gradually so that the structure remained balanced throughout the relocation process. Engineers monitored the movement in real time to ensure the building remained stable during the operation. According to international robotic statistics, China installed more than 276,000 industrial robots between 2022 and 2023. This accounted for more than half of all new industrial robots deployed globally during that period. Manufacturing companies are using robotic systems for tasks such as welding, assembly, material handling, and quality inspection. The rapid adoption of automation reflects the country's effort to maintain industrial productivity while wages continue to rise. Industrial robots have become essential in sectors such as electronics, automotive manufacturing, and heavy machinery production. These machines perform repetitive tasks with consistent precision, which improves production quality while reducing manufacturing errors. AI software allows robots to analyze sensor data and adjust their movements automatically. Some factories also use machine vision systems that enable robots to inspect products and identify defects during production. China's automation strategy is supported by large investments in artificial intelligence, 5G communications, and cloud computing. These technologies allow machines to share information across industrial networks. Data from sensors, cameras, and production equipment flows into centralized control systems that analyze performance and optimize operations. Engineers use these systems to monitor equipment health, predict maintenance needs, and improve efficiency across entire factories. Construction companies are adopting similar data-driven approaches. Sensors embedded in equipment monitor temperature, pressure, vibration, and location. AI systems analyze this data to guide machine movements and adjust work patterns. Drones provide aerial views of construction sites and create digital maps that help engineers track progress. These digital tools allow construction managers to oversee projects from remote control centers, while machines handle the physical work on site. Autonomous road construction projects demonstrate how this technology works in practice. Machines equipped with sensors can measure asphalt thickness, track the exact path of the road, and adjust compaction pressure automatically. The equipment communicates with nearby machines so that each step of the process happens in the correct order. Engineers can also stop or modify operations remotely if the system detects unusual conditions during construction. Another advantage of automation is improved safety. Construction sites often involve heavy equipment, high temperatures, and difficult working conditions. When robots perform the most dangerous tasks, the risk of injury for human workers decreases. Autonomous machines can also operate in extreme environments such as mines, tunnels, or remote regions where large crews would be difficult to manage. China has already introduced automated equipment in several other sectors that support construction and resource extraction. Some mining operations now use fleets of driverless trucks that transport materials without human drivers. These vehicles rely on sensors, artificial intelligence, and high-speed communication networks to navigate large industrial sites. The trucks can operate continuously while the software monitors their routes and schedules. The rapid growth of automation has attracted international attention, especially in the United States and Europe. Analysts are studying China's progress to understand how robotics could reshape infrastructure development worldwide. Faster construction could reduce costs and accelerate economic growth if similar technologies become widely adopted in other countries. At the same time, the expansion of automated systems raises important questions about employment and workforce training. Construction and manufacturing employ millions of people around the world. As machines take over more physical tasks, workers may need to transition toward roles that involve supervising equipment, managing data, and maintaining automated systems. Governments and companies will need to develop training programs that prepare workers for these new technical positions. Another factor that supports China's automation push is the size of its domestic technology industry. Companies that manufacture construction equipment, robotic systems, and artificial intelligence software are growing rapidly. These firms collaborate with universities and research institutes to develop new machine learning algorithms and control systems. Infrastructure development remains a central priority in China's economic strategy. Highways, railways, ports, and energy systems connect cities and support trade across the country. Automation provides a way to build and maintain these networks more efficiently as projects become larger and more complex. AI systems can analyze construction data, optimize equipment deployment, and reduce delays caused by coordination problems. Some experts believe the long-term goal involves fully digital construction environments. In such systems, engineers would design infrastructure projects using detailed computer models. Automated machines would then build those designs directly from the digital plans with minimal human intervention. Sensors and drones would work continuously to monitor the work, to ensure that every stage follows the original engineering specifications. The technology is still developing, and many automated systems still require human oversight. Engineers continue to supervise projects, inspect finished structures, and maintain equipment. However, the role of workers is gradually shifting away from manual labor toward technical supervision and system management. This transition mirrors the changes that occurred in manufacturing industries during earlier waves of automation. China's growing network of robotic construction projects shows how artificial intelligence and advanced machinery are beginning to reshape the future of infrastructure development around the world.